In this video, I'm going to go over a copy of the final exam preparation quiz. The first question on the quiz is the same question that you're going to see on the actual final exam, and it's the honesty statement for the exam. So make sure you understand that you can't access any other materials during the exam other than the materials provided within the exam. And these formulas shown here will be available on the actual final exam. All right, let's go through the questions now. Number 2, fill in the blank with the appropriate word, phrase, or symbol. A controlled operation that yields a set of results is called which? It's called an experiment. Fill in the blank. If the probability that an event occurs is 0.3, the probability that the event does not occur is, remember, the probability of event plus the probability the event does not occur have to equal 1. So the probability the event does not occur must be 0.7. Several friends chartered a boat for a day's fishing. They caught 60 fish. The table below provides information about the type and number of fish caught. Determine the empirical probability the next fish caught is a kingfish. So we see in the table there are 18 kingfish, and there were 60 fish caught altogether. And if we simplify that, we notice numerator and denominator are both divisible by 3, and we want a simplified fraction, by 6. So it's going to be 3 over 10. One card is selected at random from a deck of cards. Find the probability that the card selected is a 2. So we know in a deck of cards there are 4 2s, so this is going to be 4 over 52, which I can simplify to 1 over 13. In an experiment, if there is a loss in the long run, the expected value is, and that's going to be negative. Number 7. Now, some of these problems require a little bit more explanation, so I've created a detailed solution handout, which is also in the final exam folder. And here's number 7. The owner of an antique store estimates there's a 20% chance she will make $1,600 when she sells an antique china cabinet, 60% chance she'll make $400, and 20% chance she'll break even when she sells the cabinet. Determine the expected gain or loss. So we have 3 outcomes. She can make $1,600 with probability 0.2, make $400 with probability of 0.6, and then break even, which means make $0 with probability of 0.2. And I went ahead and put those into the expectation formula, which you can see the equation written there. And if you simplify it, you come up with an expected value of $560. And I'm going to stay right here on the next page because there's another expectation question here. It's actually a fair price question. A certain game involves tossing 3 coins. It pays 26 cents if you get 3 heads, 12 cents for 2 heads, and 6 cents for 1 head. What is a fair price to play the game? All right, if we're flipping 3 coins, there are a total of 8 outcomes. 2 outcomes for each coin. 2 times 2 times 2 gives me 8 outcomes, and I've listed those there. And now, remember looking at sample spaces that we learned about in Unit 5, we noticed that we can see there is only 1 outcome with 3 heads, so the probability of getting 3 heads is 1 over 8, and we get 26 cents for that. The probability of getting 2 heads, there's 2 outcomes that have exactly 2 heads. That probability is 3/8. The same thing for getting 1 head, there are 3 outcomes, so that's also 3/8. And I put those together again down here in the expectation formula. And I got an expectation of 9.625 cents. And remember that a fair ticket price would be when the expectation plus the price to play equals 0. So the fair ticket price for this would be $10. I'm sorry, 10 cents, not $10. Apologize for that. All right, so let's keep going over here. Number 9. A list of all the possible outcomes of an experiment is called what kind of space? And that's called the sample space. A bag contains 6 batteries, of which all are the same size and equally likely to be selected. Each battery is a different brand. If you select 4 at random, use the counting principle to determine how many points in the sample space are in the sample space when the batteries are selected first with replacement and then without replacement. So if we're going to replace them each time, and we're going to pick 6, we're going to pick 1 out of 6 each time. Then the first time we have 6 to pick from, and we're going to pick 4 of them and we're replacing. So this is going to be 6 to the 4th, which is 1,296. Now, if we don't replace after each draw, it's going to be 6 times 5 times 4 times 3, and we only have 360 different outcomes. And number 11, in this one, a man is packing up some shirts and ties for a trip. With one shirt, he could wear all 6 ties. So with one shirt, he can wear all 6 ties. With another shirt, he could wear 5 ties. And with a third shirt, he could wear only 3 ties. So how many different outfits can he make? He can make 14 outfits. For 2 events A and B, if the occurrence of either event in no way affects the probability of the occurrence of the other event, then the 2 events are said to be independent. A card is selected from a deck of cards. Find the probability that the card is less than 6 or a club. And this, I'm going to have a detailed solution for this one, number 13. So there are, for each suit, there are 5 cards that are less than 6 if the ace is the low card. So we have the ace, 2, 3, 4, and 5. So that's 5 cards, and there's 4 suits. So 20 cards altogether less than a 6. And there are 13 clubs. But in addition, there are 5 clubs that are less than a 6. So we're going to use our probability of A or B formula. So the probability that the card is less than 6 or it's a club is the probability of the card being less than 6, which is shown here, right here, and then the probability here, and then the probability that it's a club, and then finally we're going to subtract off the probability that it's, sorry, I don't know why all these windows are popping up, sorry about that. That it's a club and less than 6, which was 5 over 52. And if you go ahead and add the numerator, 20 plus 13, and subtract 5, you get 28 over 52. Numerator and denominator are both divisible by 4, so that simplifies to 7 over 13. And we're going to stay right here again on number 14. If you are dealt 2 cards with replacement of the first from a standard 52-card deck, find the probability of getting a heart on the first card and a diamond on the second card. Okay, so there are 13 hearts in the deck, so 13 over 52 for the first draw. We're going to put that card back and we're going to draw again, and there are 13 diamonds in the deck and 52 cards, so that's going to be 13 over 52. Each of those fractions simplifies to 1/4, so we see it's 1 over 16. And let's go back over here. Number 15, consider the circles shown to the right. Assume one circle is selected at random and each circle is equally likely to be selected. Find the probability of selecting a number less than 4 given the number is less than 6. So if we're going to talk about given the number is less than 6, that means we're going to be focusing on these circles here. There are 5 of those. And then what's the probability? So my denominator here is going to be 5. And of those, how many are numbers less than 4? And that's going to be 3. So the answer here is 3 over 5. Number 16, I have a detailed solution for this one. Table below shows the number of cars and trucks that used a certain toll road on a particular day. The number of cars and trucks that used and did not use an electronic toll pass on the same day were also recorded. If one of the vehicles is selected at random, determine the probability the vehicle was a car. Okay, so we're only dealing with the cars here, and we see there's 1,462 cars. 1462, and a total of 2387, and this one they want it as a decimal, so it's going to be 0.62148. And then number 17, I'm going to stay over here. This is a conditional probability question, a similar type of a table. We've got sales representatives at a car dealership were split into 2 groups. One group used an aggressive approach to sell a car, and the other group used a passive approach. If one of the customers is selected at random, determine the probability of no sale given the aggressive approach was used. All right, so we're only looking at the aggressive approaches, and there are, if you notice, there are 335 of those, and out of those, 230 were no sale. And I went ahead and wrote that down here, and I noticed that I can simplify this. I think I divided, can't remember what I divided, but it simplifies to 46 over 67. All right, number 18, another conditional probability question. From this table, we want to know what's the probability that the person watches ABN or NBS given they were a male. So if we look in the row of males, there's 140 of those, and how many watch these 2 stations, which is the first 2 there, 60 over 140, which simplifies to 3 over 7. All right, number 19. The model of car you're thinking of buying is available in 3 engine sizes, 7 different exterior colors, and 6 interior colors. How many different cars can be ordered? And this word here should say cars. So it's going to be 3 times 7 times 6, which comes out to be 126. An order of, and I have a detailed solution for this next one because you have to think about this one a little bit. An order of awards presentations has been devised for 7 people, and their names are listed there. In how many ways can the men be presented first and then the women? So if you count and look at those names, it appears that there are 4 men and 3 women. So when we deal with the men, you notice I wrote it down here. We have 4. The first choice for men has 4 choices. The second has 3, 2, and 1. That's 24 ways we can arrange the men. And then for the women, there are 3 of those, so it's 3 times 2 times 1. And then each group of men can go with each group of women, so there's a total of 144 different ways. So the correct answer is C. And let's stay right here for number 21. How many different sequences of 4 digits are possible if the first digit must be a 3, 4, or 5? Notice 3 choices there. And if the sequence cannot end in 0, 0, 0, and we're allowed to repeat. Okay, so for the first choice, again, I said there's 3 choices for the first digit. We can't use the 4-digit sequence that ends in 0, 0, 0, but we'll worry about that at the end. So for the first choice, we have 3 choices, and then the other slots, we have 10. So it's going to be 3 times 10 times 10 times 10, or 3,000. But we can't use anything ending in 3, 0. So there's going to be 3 of those sequences, 3,000, 4,000, and 5,000. So we're going to subtract 3 from the 3,000, and we come up with 2,997. All right, let's get back over here. Fill in the blank. Now we're on to statistics. A subset of population used by statisticians to make predictions about a population is called, and that's called a sample. When a sample is obtained by drawing every nth item, what kind of a sample is it? And that is a systematic sample. Identify the sampling technique. Every 12th person in line to buy tickets to a concert is asked his or her age, and that would again be systematic. A survey is undertaken by a university to gauge student satisfaction in its online MBA program. One question asks students to indicate their employment status. Employment status is what kind of a variable? Notice it puts the students into groups, so this is a categorical variable. In a company of 1,000 employees, the human resources manager randomly selects the records of 150 employees to determine whether they have completed the required annual safety testing. Is this situation describing a sample or a population? Okay, the key word here is randomly selects, so this is a sample. Determine whether the given value is a sample statistic or a population parameter. A February 2010 Gallup poll asked, in politics as of today, do you consider yourself a Democrat, Republican, or independent? 38% identify themselves as independent. So this is a poll, so this is going to be a sample statistic. In the 1900s and early 2000s, they were considered the steroids era in Major League Baseball, as many players admitted to using the drug to increase performance in the field. A sports writer decided to research the effects of steroids by comparing home run totals from the steroids era to the home run totals from an earlier decade, the 1960s, when steroids were not used. Is this an observational study or an experiment? Okay, so the researcher didn't do anything to affect the outcome, so this is an observational study. And also notice he went back and looked, or she looked at records from the past. Use the following frequency table to determine the modal class or classes. So there's actually 2 here, aren't there? There's one here, and there's one here. So the correct answer here is going to be D. There's 2 modal classes. Remember, modal class is the one with the highest frequency. A line graph with observed values on the horizontal axis and frequencies on the vertical axis is called a frequency polygon. The histogram on the right shows the starting salaries rounded to nearest $1,000 for college graduates based on a random sample of recent graduates. Determine whether the following statement is true or false according to the graph. The graph is based on a sample of approximately 600 recent college graduates. All right, so if I look at the highest bars on that graph, I notice that for the middle categories there, I've got over 300 people in this group, and I've got between 250 and 300 in this group. So these two categories right here amount to just about 600 people, and I've still got many other classes to add in. So obviously there's more than 600 graduates summarized in this table. So it's false because the total number of data items is actually larger, so the correct answer is C. The frequency polygon to the right shows the distribution of IQ scores. Determine if the following statement is true or false. The IQ score that more people had than any other IQ score, and which the scores fall off in a symmetric manner as the deviation increases or decreases, is the IQ score of 110. So basically, they're talking about the middle of the distribution. And if you notice on this graph here, the middle of this distribution is actually 100. So this statement is false. A piece of data that occurs most frequently is called the mode. Okay, for number 34, I've got a detailed solution over here. We want to do a mean. So in order to do the mean, what do? We add up all the data values, divide by the number of data values. There were 12, and so I got a mean of 216.5, which is answer D. The next question was for the median, and I noticed these are already in ascending order, and there are 7 of them, so the median is going to be the middle value. In this case, it's 22, so the correct answer here is C. And then number 36, find the mode or modes. I put them in ascending order so I could see a little bit more clearly if there are numbers that appear more than one time. And I see 39 appears 3 times, 49 appears 2 times, so the mode is going to be 39. The measure of dispersion that measures how much the data differ from the mean is called the standard deviation. Find the range for the data below. The range is the difference between the largest and the smallest in the data set. In this set, the largest value is 18 and the smallest is 1, so the range is 17. Find the standard deviation. I've got a detailed solution for this one. First thing you need is the mean in order to do the standard deviation. And the mean here, I add up the data values. They're 9 and divide by the number of data values, and I get 10.89. And then I created my little table where I took each of the data values in the left column. In the middle column, I took the data value minus the mean. Notice that adds up to 0. In the third column, I took the second column values and squared them. And then I added those all up. And then I used the standard deviation formula, which is to take that sum of the deviation squared, divided by n minus 1, and take the square root. And the square root is approximately 7, a little bit more than 7, and the correct answer there is going to be C. A measure of how far, in terms of standard deviations, a given data value is from the mean is called a z-score, or what other kind of score, and the other name we use for that is a standard score. A distribution that has a tail on its right is said to be skewed to the right, and a distribution that has a tail on the left is said to be skewed to the left. Give an example of a bimodal distribution. So bimodal means it would have 2 peaks if we looked at the histogram. So we're looking for a description here that might have 2 different populations mixed together, and the most appropriate answer for this would be D, where we have the weights of an equal number of men and women, because we would tend to think that men on average would weigh more than women. Okay, number 43, got a detailed solution for this one, and we want to know what percent of light bulbs are going to have a lifespan between 9,480 hours and 12,520 hours, given a mean of 11,000 hours and a standard deviation of 760 hours. So what I take to do with this kind of a problem is figure out the distance from the lower bound to the mean and then from the upper bound to the mean and see how many standard deviations it is. And this problem, in both cases, I found 2 standard deviations, and I know from the empirical rule that 95% of the data will fall within 2 standard deviations, so the correct answer here is 95%. Number 44 and 45 want us to find z-scores. So the first problem, I want to find the z-score for 76 when it comes from a distribution with a mean of 60 and a standard deviation of 8. So 76 minus 60 is 16, divided by 8 gives me a z-score of 2. And then for number 45, I want to find the z-score for a value of 12 when it comes from a distribution with a mean of 11 and a standard deviation of 4. So I take 12 minus 11 is 1/4, and my z-score is 0.25. And that is our review of the a copy of the midterm prep quiz. Hopefully this will help you get ready for your actual final exam.